Good morning. I'm going to say hello today to Veronica and anybody else that happens to be watching this. I'm betting it is probably just Veronica for now, though. And I want to welcome you back. It's great for me to actually be back in school, and I really am looking forward to seeing you again as well. So, today we're going to go through what basically is the first day of math analysis, and we're going to give you a little bit of background on what the class is about. And we're also going to go through some stuff that ties together things you've done before and some stuff that's totally new. This is the very first part of the book, and you'll have an assignment then that deals with applying that and hopefully making sure you know everything. We're using some new technology here, and I'm going to tell you that there are some places where probably my picture may block a little bit of the PowerPoint. I'm going to need to get used to that when I prepare things, but hopefully everything will work okay. You, of course, have already signed up for the Google Classroom for this class. Otherwise, you wouldn't be watching this. We're going to use this basically whenever we have people that are not able to be in class. In general, though, I'll be doing things kind of like I do in class generally, and giving some notes, giving time to work in class, and then going through things at the start of the next day. So we're going to start by finding out a little bit about just exactly what math analysis is. Because while it's a name we have given to this class forever, there are a lot of schools that don't have a course called math analysis. And sometimes people will wonder, so just what do you do in this class? Well, the word analysis, it comes from the fact that what we do is we analyze different things, different mathematical objects. Analyze basically means you're going to look at them in detail and find out all about them. And that's what we're going to do in math analysis. The most common thing that we analyze in math analysis is functions. You remember functions were like rules that you could use to take numbers and turn them into something else. We are going to do a lot of stuff that involves analyzing functions. Sometimes it'll be numbers we analyze. We try and figure out what do different numbers have in common, how are they different from other things. We'll also take a look at analyzing graphs, analyzing shapes, and something you haven't really done before is analyzing logical arguments. I have a little cartoon there that says penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. Now, that is not a good logical argument. And what we'll eventually get around to doing is figuring out, okay, so what's wrong with that? Why isn't that a good logical argument? In the process of doing all this analysis, we're going to be looking at how different branches of mathematics are connected. And even though I can't see it on my screen, I'm betting that probably the bottom of that is getting cut off by my face right now. But again, we're looking at how different branches of math are connected. You've studied things like algebra, geometry, trigonometry, and now what we want to do is look at what does one of those have to do with another? How are they connected? We're going to try and look at patterns. And we'll also look at how math relates to things that are outside math. How does it relate to science, music, art, all kinds of other things? So the key thing is analyzing, looking at stuff in detail. Again, we call this course math analysis, but it can have a lot of different names at other schools. Sometimes when you do stuff like filling out the form to take the ACT, or when you're applying for scholarships or applying for admission at different colleges, they may ask you what math courses you've taken. And sometimes math analysis is not a choice, but if it does say something like pre-calculus, math 4, those are very good bets for what this course is going to be. the book that you're using is literally called Pre-Calculus, and so, that is a pretty good bet for what you might choose. Some schools will call it functions. There's sometimes it also will be called mathematical modeling. All of those are basically just different ways of saying the same thing. So you have a book that looks like what you see in the picture there. Interestingly, we actually got these books last year, but the people that took this class last year pretty much didn't use them at all. That's because those books came shortly after the beginning of the year, and right after those books came was when I was sick and in the hospital and trying to just basically keep things going. And so you're going to be the group that ends up actually using this book the way it's supposed to be used. And this book actually starts off with a chapter that they call Chapter P. So an obvious question is, so what does P stand for? Well, it doesn't stand for peach, and it doesn't stand for pig, or potato, or parrot, or poops, or even pterodactyl. None of those is what Chapter P in your book stands for. What it does stand for is prerequisites. And prerequisites are the things that the authors of your book feel that you're supposed to know before you get into what's actually new in math analysis. It's what they expect you to know going into stuff. And especially after the weird online stuff we did last spring, this is actually not at all a bad place to start. It's actually kind of where the people that took this course last year actually ended the course. And for you, it's more or less where we're going to begin. What we're going to do is review a lot of stuff that you did before, and we're also going to look at some brand new stuff as well. Hopefully, it will prepare you for what you need to know for this course, but it also may be a pretty good preparation for some things like the ACT or taking placement tests at colleges. There's actually a lot of good uses that going through this stuff can have. So we're going to start by taking a look at an idea that both combines a review of things you should know in your sleep and some stuff that's new but also pretty easy. And it's what's called the idea of intervals. And we're going to start by taking a look at what you do in fact already know. So if I gave you some problems that look like what you see here, you should be able to take these inequalities and graph them on a number line. Clear back in Algebra 1, you learned how to graph stuff like x is less than 4 or x is greater than or equal to negative 2. And I've got a couple of other ones that are more advanced than that, but they're still not difficult. You should know that if you had something like x is less than 4 on a number line, it's going to look like what I have on the left, and x is greater than or equal to negative 2 looks like what I have on the right. The things that matter, of course, are that you use a circle if it's not equal to the number. You may fill in and use a solid dot if it is. And you, of course, also want to shade the correct direction, which way is less and which way is greater than a given number. The other two examples that I have, what we're really looking at is what we call an interval. It's what's between two numbers. We're basically saying 1 is less than x, which is less than 3. We want the numbers that are between 1 and 3, and that's why my answer ends up being like a line segment that starts at 1, it goes to 3, and since I don't have any equals there, I just have circles at the end of that line segment. The next one says negative 4 is less than or equal to x, which is less than or equal to 0. It's the same kind of thing, except I do fill in the endpoints on that line segment. And again, those are intervals. They're just like the segment that starts one place and ends another. Now, today we're going to expand that just a little bit. And we're going to talk about what's called interval notation, which is just a different way of writing those same problems so that they look different, but they're just asking the exact same questions. The interval notation uses parentheses and brackets instead of greater than and less than signs. That's basically what the difference is. We just looked at two problems where the answer was like a line segment and interval. Here I have those exact same two problems written using interval notation. The first one is saying I want all the numbers from 1 to 3, but not those two endpoints. And the bottom one is saying I want everything from -4 to 0, and I do include those two endpoints. Now, a lot of times people will look at that top one and they say it looks like the 0.13. And it does. It's written exactly the same way as the 0.13. But you get from the context of the problem that this is supposed to be an interval, a line segment, and I just want all the stuff from 1 to 3. You should notice, looking at those two examples, that when I have parentheses, I don't include the endpoints. That's like just less than. And when I've got square brackets, I do include the endpoints. That's like less than or equal to. So again, parentheses 1 comma 3, that means, yeah, I don't include stuff, but I want everything from 1 to 3. Brackets, -4 to 0. It's everything from -4 to 0, but you do include those endpoints. So here's a question for you to think about. It says, so what is parentheses -2 comma 4 brackets? And of course, I'll have people actually answer this question in class, but hopefully what's going through your mind is something kind of like this, that I don't include -2, but I do include 4, and I've got to have all the stuff in the middle. And that's really all interval notation is about, is how do you go about expressing all of that. So here's another graph. And the question is, how would I write something like x is greater than or equal to -2 using interval notation? I'm going to write something that's got brackets and or parentheses, and I want it to mean the same thing as x is greater than or equal to -2. So we want to know, how would we do that? And it turns out that what you do looks like this. I put an infinity at the end of it. And I have a bracket because I do include -2. I start there and I go all the way on forever, which is why it's infinity. Now it does turn out that whenever I use infinity, I always put a parentheses rather than a bracket with it. That's because you can never really reach infinity, and so it just kind of shows we go on forever. So brackets, -2, infinity, and parentheses. So think about it for a minute. What would this be? Problem, of course, is x is less than 4, but how would I show that using interval notation? And it turns out that what it's going to look like is -infinity to 4. This time I've got parentheses on both sides because I don't include 4. I've got the circle there. And again, anytime there's an infinity, you always use parentheses. Sometimes when you see a graph that is showing an interval on a number line, instead of using circles and dots like you've done ever since junior high, what they'll do instead is they'll use that same parentheses and brackets to show whether or not you include things. This is actually the standard way of graphing on a number line in most of the world. Whenever we've had exchange students and they've taken classes at Garrigan, I'll always I can always tell where they're from by how they graph on a number line, and everybody in Europe always uses brackets and parentheses instead of circles and dots. It means the exact same thing. If you see a dot, it's the same thing as a bracket. If you see a circle, it's the same thing as parentheses. So this chapter P that we're in, the main thing that's new, at least so far, is that idea of interval notation, using the parentheses and brackets to communicate greater than and less than. What we're going to also do is review a bunch of other stuff in this section as well. You're going to see some questions in the assignment I give that go back and talk about sets of numbers, which we did like literally a year ago this week. We learned about things like natural numbers, where it's like 1, 2, 3, 4, 5, whole numbers, where you toss in 0, integers, which is like positive and negative whole numbers, rational numbers, anything you could write as a fraction or a mixed number, irrational numbers, which was all the weird stuff like pi and square roots, and of course reals, which was everything that you could write on a number line. We'll review all of those different kinds of numbers. You're going to see some questions where it asks you about different types of numbers. Most of those you really should be able to do pretty straightforward. And a lot of what's going to happen in the first couple of assignments we do is our goal is to find out what people do and don't know. And we'll do a quick review on the stuff that you've forgotten and make sure that, yeah, we're good to go with the rest of it. This first section is also going to review some of the properties that we learned. You might remember things like the distributive property, where you get rid of parentheses, or the commutative property, where you can flip around the order stuff's in, identity, where you can multiply by 1 or add 0 and you get back what you started with, or inverse, where stuff cancels out. So it's going to look at some of those properties, and one thing that actually I'm betting a lot of people may have some issues with is some rules of exponents. They're things you've all done before, but some of them it's either been a while or they came up real quickly when we were doing the stuff online last spring. And so we're going to see again what people do and don't know. And then we're going to kind of go back and review some of those. So that's what our first day's notes are about. Again, we're looking at just the basics of where everything comes from and interval notation, and then we'll be getting started with some of these other things that review what you've done before. That's where we're at right now. I hope you're doing okay. And again, hopefully not getting too bored with everything. And I'm looking forward to seeing you real soon.